Good morning all. Welcome to next lecture. In the last lecture, we discussed the Cartesian product and its properties. We said that Cartesian product is a set of all ordered arrangements of elements in a set. Today, we are going to introduce the concept of relation and functions. See, the concept of relation is closely related to the Cartesian product. In fact, we can say that the relations are often defined using Cartesian product. See, relation is a set of ordered pair which is often a set of input and output and represents relationship between two values. And we know a relation between two sets, for example, set A and set B is the set of all elements of ordered pairs A and B, where element A is an element from the set A and B is the element from the set B. And this relation is a subset of the Cartesian product A cross B. It is nothing but it is the subset of Cartesian product A cross B. So it will be relation will be a set of ordered pairs where the A belongs to set A and B belongs to set B. Let us consider one example. Set A is equal to 1, 2, 3 and set B is equal to x, y. We can define a relation R between A and B using Cartesian product. See, if R is the subset of A cross B, that is a relation R from A to B, which is having the ordered pair that is 1x, 1y, 2x, 3y. See here, in each ordered pair in relation R is an element of a Cartesian product A cross B. Here we have two sets, set A and B. So we can say that we are taking a subset of this particular Cartesian product of A cross B. For instance, 1x, the pair 1x, which indicates there is a relation between 1 in set A and x in set B. If A and B are two sets, then the relation R from A to B is the subset of A cross B. That is, relation is a subset. It's nothing but it is subset of A cross B. It is the subset of relation is the subset of A cross B. Now we can discuss now different types of relation. See, the first one is void relation, where relation is equal to R is equal to 5. If R is an empty set, that is, there are no ordered pairs in R, it is called a void relation, because it means that there are no elements in set A that are related to any elements in set B under relation. That is, there is no elements in the relation. In this case of void relation, there is no ordered pair in this particular relation. Now let us take the another type of relation, that is universal relation, where relation is equal to A cross B. In the case of a universal relation, it is a relation is equal to A cross B. See, a universal relation is defined the Cartesian product of two sets, set A and set B, and it includes, see, all the possible ordered pairs where the first element is from set A and the second element is from set B. In this relation, every element from set A is related to every element in set B. That's why the universal relation is equal to the Cartesian product, because every element from the set A is related to the every element in the set B. If it is so, then the universal relation, that is R, is nothing but it is A cross B. Now consider the another type of relation, that is binary relation, which is also known as it is relation defined on A. See, a binary relation on a set is a specific type of relation. See, where the set is involved is the same. That means it is the relation from a set to itself. It is the relation from set to itself. It describes how the elements within the same set are related to each other. It is how the elements within the same sets are related to each other. See, for example, a binary relation on a set A is nothing but we can say that it is the subset of the Cartesian product A cross A. It is the Cartesian product or subset of the Cartesian product A cross A, because it consists of an ordered pair AB where both A and B are the elements of the set A, same set A. So if R is the binary relation on a set A, it can be mathematically denoted as, see, R is the, that is relation here, it is the subset of A cross A. R is the subset of A cross A. Consider an example of a set, that is set A is equal to 1, 2, 3. A binary relation R on A could be, see, 1, 1, 2, 2, 3, 3. See, which indicating that each element is related to itself. Each element is related to itself here. See, it is a special case of a relation which is generally known as it is identity relation. That is 1, 1, 2, 2, 3, 3. Is a special type of relation which is generally known as it is identity relation, because it is an ordered pair. It is an ordered pair where the first and second elements are from the same set for each pair. It is an ordered pair where first and second elements are the same for the each pair, and that's why it is called an identity relation. See, another type of binary relation, see, it is a cyclical relation. For example, it could be 1, 2, 2, 3, 3, 1, which shows a cyclic relation. How? See, where 1 is related to 2, 2 is related to 3, and 3 is related to 1. And it shows a cyclical nature. That's why this relation is known as cyclic relation. Generally, we can say that a binary relation is a subset of Cartesian product A cross A. That's why it is relation is the subset of, this binary relation is a subset of A cross A, which consists of all possible ordered pairs of elements from set A itself. So this is the case of a binary relation. Now, besides the set notation, there are other ways to write a same relation. That is, what are the various ways to represent the relation? See, in a set or notation, we are already used both roster method or by set builder method, which we were already discussed earlier. Just like set notation, the relation can also be represented by using a tabular form, or maybe you can also represent by using a graph, or maybe by using mapping diagram. See, a tabular representation is given here. See, it is the representation of a relation that can be created using a particular table where each row corresponds to an ordered pair in the relation. See here, the column of the table represents the components of the ordered pair. So in this way, tabular form, we can pair the elements. See, 1 minus 1 is paired with 2, minus 1 is paired with 3, 0 with 4, 1 with 5, 2 with 6. We are just shown the relation in the form of a tabular representation. Now, we can also express the individual pairs relation by using the graphical method. See, the graphical method is given here, or graphical paper is given here. By locating them at a specific intersection grids. See, on the grid, we have a specific intersection points here. At this particular intersection point, for example, at this particular point, see, the x coordinate is equal to 4 and y coordinate is equal to 2. So it is 4, 2 is a particular pair. And here we have another cross. See, at this particular point we have another pair, that is 2 and 5. And the similar way, at this particular point, see, we have a minus 4 value of x and 3. So it is minus 4 and 3. So similar way we can show us the remaining points. So each point is typically represented x and y, where x is the horizontal coordinate and y is the, it is vertical coordinate. So graph paper is therefore considered as a very useful tool for visualizing the relation. Now we have another one, which is the mapping diagram. See, in the case of a mapping diagram, it is also a way to represent the relation between two sets using the arrows. By using the arrows, we are representing to show how each element in the first set is paired with element in second set. So the elements and their pairing are usually represented by points and arrows respectively. So here A is related with 1, so A1 is one pair, B2 is another pair, C3 is another pair, D and 5 is the another pair. So it is very clear that relation between sets is a collection of a ordered pair containing one object from each set. Now, let me introduce the concept of domain and range, which are two important parts when we make a particular relation. Every relation must have, some domain and range. So what do you mean by domain and range? See, domain is nothing but it is a collection of first value in the ordered pair, or it is the set of all inputs x values, or it is also called, it is a pre-image. It is also called a pre-image. Mathematically, we can write a relation R from A to B. Then, what is domain here? A will be the domain. A will be the domain. Okay. Now, the codomain, see, the codomain means the set of all possible elements, or we can say that it is whole set B is called a codomain of a particular relation R. See, mathematically we can represent, see, if R is the relation from A to B, then this B, the elements included in the set B is considered as a codomain. So B is the codomain of a relation. Now the third concept, which is range. See, range is a collection of second values in the ordered pair, or it is the set of all output values, or maybe it is also called an image. Okay. So in other words, the set of all starting points which are called the domain and set of all ending points are called a range. So here you might little bit confused in terms of codomain and range. It's more or less it is look like a same. See, the codomain is the set of all possible values in the set B. But it is not necessary that every element in the codomain is actually paired with or reached with the particular pair with the domain. So a range is a subset of a codomain. A range may be a subset of codomain, and include only the elements the function hit or that maps with the from the domain. Therefore, codomain is a broader set that include all potential values, while range is nothing but it is the subset of the codomain, and the whole set B is called codomain of a relation R, and not that the range is a subset of codomain. So we are writing here range is a subset of the codomain, and the entire set B is known as it is the codomain. I hope you are understood the differences between domain, codomain and range. Now let us consider an example of a domain and range. We will explain it by using an example. Suppose we have a relation R that is having the following pairs C -3 2, -3 4, 0, -2, 2 5 4 2. See here the set of all starting point is termed as a domain. So it is starting points are here, it is -3, -3, 0, 2, 4. And the set of all ending points are known as it is range. So it will be 2, 4, -2, 5 and 4. So we will get a domain. So domain is starting point, that is -3, -3, 0, 2, 4. And at the same time range is the ending point, that is 2, 4, -2, 5, 2. It should be noted here, see here, we are not considered the duplicate, that is -3, -3 is repeated here. So while writing the domain and range, we are not going to consider the duplicates. That means we write the value only once and also write it in increasing order. That's why we wrote -3 only once in the domain and 2 only once in the range, even though they are repeated. Now consider the example of a domain, codomain and range. Consider an example that is set A is equal to A, B, C, D and set B is equal to 1, 2, 3, 4, 5. We can show a relation in terms of these two sets by using mapping diagram. See, by using the mapping diagram I have shown here, A is paired with 1, B is paired with 2, C is paired with 3 and D is paired with 4 and 5 is not paired with any pre-images with the element in the domain. So we can write this mapping relation by using a ordered pair, that is A is paired with 1, so A1, B with 2, B2, C3 and D4. See here, the domain is the set of all elements from which the function take its input. In this case, see the domain is a set A, that is A, B, C, D. The domain here A, B, C, D, see these are the domain, and because these are the elements from which the mapping is defined. Similarly, the codomain is the set of all elements in the second set, that is set B. So the all elements here it is 1, 2, 3, 4, 5. So set B is the codomain, that is 1, 2, 3, 4, 5. All the elements in the codomain is considered as a codomain. See, because these are the potential output values. Now see what are the range here? Range is having only 1, 2, 3, 4. Only 1, 2, 3, 4. Range is considered only those elements which have corresponding pre-image. So 5 does not have any pre-image here. So the codomain include all elements in the set B, that is 1, 2, 3, 4, 5, even if they are not all used in this specific mapping, that is 5 is not used here. The element 5 does not have any pre-image in the set A, even then it is a relation. I hope you understood the differences between the domain, codomain and range. Now after understanding the concept of relation, now we can move to define another concept, that is function. See, we can define a function is a special kind of relation in which there is only one output for each given input. In other words, it is well-behaved relation. A function is a well-behaved relation. Well-behaved in the sense that it has some special features. A relation from a set A to set B is said to be a function, see, if every element of set A has only one and only one image in set B, then only it will become a function. That means a function is a relation between a set of input, that is called domain, and set of possible output, which is called codomain, such that each input is related to exactly one output. Just like a relation, a function is also a set of ordered pair. However, every x value must associated to only one y value. That is the essential characteristics of a function, in that it gives a unique output for each input. It will give a unique output for each input. Mathematically, we can write it is, see, a function f is the function from A to B. F is the function from A to B. The notation means that f is the function and A is the nothing but it is domain of the function. This A is domain and B is the codomain, and we can read this f is the function from set A to set B. It indicates that each element in A is associated with a unique element in set B. Like in relation, see, a function is also a set of ordered pair. However, every x value must be associated to only one y value. So it is to be noted that all functions are relation. That's why all the functions are relation, but not all relation are function. A function are specific subset of a relation that shows, a strict one-to-one relationship, a one-to-one relationship between elements of a domain and codomain. Now consider one example in terms of mapping diagram. See, this is a relation, is a function from set A to set B, where every element of set A has a unique image in the set B. We can say that it is a function from set A to B, where every element of A has unique image in B, which is defined as a function from A to B, which is R is the relation, which is, see, what are the ordered pair? A to 1, B to 2, C to 3, and D to 4. It is B to 5. Wrongly written it is, here it is 4, but it is 5. So we observe that in a function, no two ordered pair have same first element. Symbolically, a function we can written as, see, it is f is the function from A to B. It is the f is the function from A to B. See here, for each element of the set A, there is exactly one corresponding element in set B. This is the unique property that ensures that mapping is well behaved. And it is also distinguish function from general relation, where an input might be associated with multiple outputs. The absence of multiple output for the same input is one of the crucial characteristics of the existence of function. Consider another example and check whether the following relation is shown mapping diagram is a function or not. See, it is a function or not. See, taking the pairs from this diagram, we get the relation is, what are the various pair? 1, 0, 1, minus 1, 2, 3, 4 and 10. So these are the pairs here. See here, we can see two pairs, that is 1, 0, 1, minus 1, have same first element, that is first element is 1 and 1 here. So the domain here it is 1, which is repeated here, which means that the input 1 is associated with two different outputs, that is 0 and minus 1. So here it is 1 is associated with 0 and minus 1. So each input should have a unique output in a function. So that condition is violated in this particular situation, and so it is a relation, but it is not a function. since we have a repetition or duplication of x values with different y values. Now, consider another example in terms of table. See, domain and range is given here. A, B, C, D is the domain. B, C, B, C is the range. Taking the pairs from this particular diagram, we will get the relation is pairs are A, B, B, C, C, B and D, C. See here, none of the domain are repeated. A, B, C, D is none of the domain are repeated. So this relation is a function. However, it is okay with two or more values in the domain to share common values in the range. See here, A is shared with B, C is also shared with B. So range is the same, but it does not matter. Elements A and C is the domain are share the same value of B in the range, and B and D in the domain is share the same element of C in the range. This is a relation and still it is again a function. So this is a relation and still it is a function. Now consider another example, taking the table. See, we have the domain and ranges given A, B, C, 2, 2, 3, 4. So possible pairs are here paired A2, B3, C4. See, do you think this is a function? See, this is a relation. It is not a function. Why? We have a repeating values of x. A is repeated. Repeating value of x, but they have been associated with the same value of y, 2 and 2. So the point A2 is repeated. A2, pairs A2 is repeated here or written twice. So for the relation to be a function, each element in the domain must be associated with the unique element in the range. So this table can be cleaned up by removing one repeated value, that is A2. The first one is removing this repetition in the ordered pair. Then this removes the duplicate ordered pair A2, and accordingly now each element, now let us look at the new elements A2, B3 and C4, and the new element, the domain are A, B, C and the range is 2, 3, 4. So this become a function. Okay. Now consider another example by using a following mapping diagram. See, is it a relation or function? See, the element 7 in the domain is not being paired with any element in the range. In a function, we are already said that every element in the domain must have corresponding element in the range. Therefore, it is not regarded as a function because one of the element in the domain is not paired with element in the range. Every element in the domain must have some kind of correspondence into element in the range, for it is considered as a relation at least. Since this is not a relation, and therefore it can't be a function also. So it is not a relation and it can't be a function as well. Now let us look at what are the difference between function and relation. See, the first point is every function is a relation, but every relation is not a function. See, a function we know is a special type of relation where each input, that is element in the domain, is associated with exactly one output or element in the codomain. It means there are no repetition of input and each input has unique output. So a relation is more general concept and it is any set of ordered pair, and it may or may not have property that every element in the domain is associated with a unique element in the codomain. That's why we are saying every function is a relation, but every relation is not a function. Now the second difference is, if R is the relation from A to B, then the domain of R may be a subset of A. But if f is the function from A to B, then the domain of function must be A. See, in a relation R, See, the domain is the set of all first component of the ordered pair. Not all the elements of A may be used as an input. In a function, the domain is the set of all possible input, and every element of the set A must be associated with every element in set B. So the domain of function is exactly set A. The third point is that, see, in relation, any element of set A can be associated to the more than one element in set B. But in a function, every element of A associated to only one and only one element in set B. Which means, in a relation, an element in the domain can be associated with multiple elements in the codomain. The repetition of input is allowed. There is no problem. But in a function, we are already said that the repetition is not allowed. Each element in the domain is associated with unique element in the codomain. So there are no repetition of input, and each input has unique output in the case of a function. So these are the various difference between function and relation. Now we have a questions, which of the following relation are function, and write down their domain and range. See, the first one, we have some set of pairs is given 1, minus 2, 3, 7, 4, minus 6, 8, 1. See, is it function or relation? See, here the domain are the first elements 1, 3, 4, 8, and the range are minus 2, 7, minus 6, 1. We can say that this particular pair is considered as a function because none of the domain are excluded or repeated in a relation, so it is considered as a function. Now the second one, do you think this is a function? Consider the domain and range here. The domains are 1, 1, 2, 4, range 0, minus 1, 3 and 10. See, it is not a function because the domain, the element 1 is repeated. Here 1 is repeated in the domain, so it is not a function. The third relation, that is AB, BC, CB and DC. See, what are the domain here? Domain ABCD. Range here, it is BC. See here, none of the domain are excluded or repeated. So it can be treated as a function. It is also a function. Now consider the fourth one, 2, 4, 3, 9, 4, 16, 5, 25, 6, 36. See, write down its domain and range. Domain are 2, 3, 4, 5, 6, range 4, 9, 16, 25, 36. Here also, none of the domain are excluded or repeated, so which we can consider as this is also a function. Now the fifth one, see 1 minus 1, 2 minus 2, 3 minus 3, 4 minus 4, 5 minus 5. See, we can write down the domain here 1, 2, 3, 4, 5 and range are minus 1, minus 2, minus 3 and minus 5. See, what about this function? This is a function. This is also considered as a function because the domain is not repeated. Now, the last one, that is AB, A2, B3, B4. What are the domain here? AA, BB, range B2, 3, 4. Is it function? It is not a function because the elements in the domain are repeated AA, BB. So it is not a function because the domain A and B are repeated. So let me conclude here. In this lecture, we defined and differentiated the concept of relation and function along with suitable examples. In the next lecture, we will discuss the different types of functions. We will see in the next lecture, and thank you.